In this video, we will explore the biggest advantage of using GPUs to accelerate simulation, that is, to enable scene-level parallelism so that we can train robots in many environments simultaneously. Let's start creating and activating a new Python environment. We will call it gs.gpu. The next step is to install PyTorch, selecting the compute platform as CUDA. Navigate to pytorch.org, select the suitable options for your system and copy the pip install command. Back to the terminal, run the command and wait until the installation is completed. Next, we need to install Genesis on this environment. This is as easy as calling pip install genesis-world. For this example, we will build on the Hello Genesis example from the last tutorial. Let's create a new directory called parallel and copy the Python script that we've been working on so far. Since we will explore the parallel simulation capabilities of Genesis, we rename the file to parallel.py. We then proceed to open the new directory on a terminal, activate the Genesis GPU Python environment, and open VS Code. As a reminder, in this example we loaded a single plane object and a Franker arm into the scene. We also added a camera for video recording. And through different control modes, initially the robot moves to 3 predefined positions using position control, holding each pose before moving to the next. In addition to numpy, let's import torch. And in the gs.init command, let's change the backend from CPU to GPU. gs.gpu is a shortcut to instruct Genesis to select a backend based on your system, for example gs.CUDA if CUDA is available, and gs.metal for Apple Silicon devices. As an initial test, let's change the name of the output video file, and then run the simulation by running the script. Once Genesis is initialized, you will notice that Genesis is now running on your graphics card, with the corresponding backend. For example gs.CUDA, as shown in this example. As we've seen before, while the simulation progresses, the interactive viewer will display the results. Now that we confirmed that we can run a simulation on GPU, we can interrupt this simulation by closing the viewer. In Genesis, creating parallel simulation is as simple as adding an additional parameter nNs to the build scene command to tell the simulator how many environments you want. In this example, we will run 5 parallel environments. We define a variable b to specify the number of environments, and then specify the nNs option in the build scene command to create b batched environments. We also specify the env spacing option to distribute all the environments in a grid with a distance of x, y, in meters between each env. Here we use a 1 by 1 meter spacing. Now let's take a look at how we send control commands to the robot using PyTorch tensors. Since our simulation runs on the GPU, it's more efficient to use torch.tensor instead of numpy arrays. This reduces the data transfer overhead between the CPU and GPU. We also make sure to place the tensor on the Genesis device by setting device equals gs.device. This ensures the tensor lives on the GPU and avoids unnecessary memory copies. To control multiple robots in parallel, we need to add a batch dimension. We do this using torch.tile, which replicates the same command across all environments. In our case, we've created 5 environments, so the batch size is 5. By tiling our control vector with shape 5, 1, we generate a tensor with 5 rows, 1 for each robot, and 9 columns, 1 for each joint. This allows us to send the same command to all robots at once, using the exact same API as for a single robot. The only difference is that now, the input tensor must include this extra batch dimension, 1 row per environment. We need to repeat this for each of the controls that we created previously. Five is a small number of parallel environments, but for larger numbers it might be better to turn off the viewer by setting Show Viewer to false in the scene options. We can then run the script. Once the simulation finishes and the camera recording is saved, we can open the video. We can see the 5 Franker arms performing the same movements in the 5 environments. Genesis supports up to tens of thousands of parallel environments and unlocks unprecedented simulation speed this way. Genesis tests performed on RTX 4090 with a batch size of 30,000 environments gives you a futuristic simulation speed, over 43 million frames per second. This is 430,000 times faster than real-time. By following these steps, you have successfully installed Genesis GPU and learned the fundamentals of controlling a robotic arm in parallel environments.